This is Dr. John Bergduff. In this video, we're going to explore the definition of absolute value. There are actually two definitions of absolute value that you typically see. The first definition, which is an informal one, is quite all right for the elementary school level, but to apply the concept more fully in algebra and above, you need a more formal definition, and I'd like to show you both. So the informal definition is basically based on looking at a number line. The absolute value of a real number a is the distance between a and 0 on the number line. I'm going to draw a number line here and mark it off to include some both positive and negative numbers. And I want to look and see about the definition, or about the value of the absolute value of 2. Now, it's the distance or the number of units between 0 and 2. If I count units, there are 2 units between 0 and 2. That means the absolute value of 2 is 2. If I want to look at the absolute value of negative 3, negative 3 is down here. The number of units between negative 3 and 0 is 3. Distance is not considered negative. It's always considered positive. So the distance between negative 3 and 0 is 3. Distances are always positive. And maybe for one more example, we'll look at the absolute value of 0. Well, the distance between 0 and 0 is nothing. There is no distance there, so that absolute value is 0. And all that's pretty simple. But how does that connect in with the more formal definition? The formal definition is written like this. For any real number a, the absolute value of a is equal to a if a is a positive number or 0, but it's equal to the negative of a if a is negative. And if you look back at the previous slide, this looks a little contradictory because absolute values are distances and distances should be positive. But if you look at that second line, it looks like we're saying that somehow the absolute value will be negative. So let's jump right to that one because that's going to be the strange one. So from this formal definition, if I'm looking at the absolute value of negative 3, since negative 3 is a negative number, the absolute value of a is the negative of that number. But what is that? That would be the negative of 3. That is how that turns out to be positive, because the negative of a negative is positive. The definition is still fine if you look at positive numbers. The absolute value of 2, because 2 is positive, the absolute value of 2 will just be 2 itself. And the absolute value of 0, because that would also fall in the first category, would be 0 itself. So the formal definition actually matches the informal definition. Hope that helps.